So this is now the size of a whole, and I had 3/8 of it. Now I want 4/3, so that would be 4 pieces of a third of the original. So I take this original, I need another color.
You black?
I don't have anything.
You want a black one?
Do you have black one?
Yeah, occupational, oh, no, blue, sorry.
Just, it's okay, purple.
I'm sorry. So, that second piece, I want the, now I want a bar that's 4/3, so it's 4 groups of 3, or 4 pieces of this bar that is going to be divided into 3 pieces. So I'm just going to take this and create thirds. So there's 3 of my thirds, but I need a bar that's 4/3, so I can extend that out. Add enough thirds to it, and there's my new bar.
Beautiful.
That was the original, and now this is a 4/3 bar.
What do you
Does that make
think?
sense? Mm-hmm.
Does it make sense?
Very clear.
Do you agree? Do you have any comments? Oh, we have to applaud. I always forget that my students have to remind me, we must applaud. Yes.
When Sue did this, it was brilliant, and she wanted to be able to do it algebraically, but,
Yeah.
you know, this is a great way to do it. Very visual, very clean.
And in fact, it then, out of this emerged what I want to tell you. So let's see if this makes sense now.
Okay, good.
So first of all, just in case nobody did it, I had my slides ready to go. But my slides just do what Sue did.
One nice though.
Yeah. Well, so the idea was, now listen to what happened here, what Sue said. She started by taking the bar and cutting it up into 3 pieces, right? Because she knew that was 3/8 of something. And the something is that the entire bar that you drew that had 8 parts. So you cut it up now into 8 equal parts. Now in your case though, since we didn't have the whole thing, you had to cut that thing up into 3 parts, and then you had to replicate that third, or that 1/8 piece 5 more times, right? So you had to cut it up, then you had to replicate 5 more times. And then once you knew that that represented a whole, we knew we wanted 4/3. So you took that, cut it up into thirds, and you had to replicate that how many times?
Another one.
Another time for a total of 4. So we needed to have 4 copies of those 1/3 pieces to get the 4/3. So what that brings us to is describing fractions. I say, in addition to, please don't read me wrong here, in addition to part to whole, division, ratios, whatever, in addition, we have to think of it as partitioning and iterating. Or what I usually say in my classes is just cut and copy. But that's the same idea. So first, when you see 1/8, what 1/8 has to mean, in my mind, 1/8 has to mean, it's the amount we get by taking a whole, cutting it up into 8 equal parts, and taking one of those parts. Now, when I do this in my Math OA2 or in my 156 class, we're going to do it. You guys just can't imagine it. Imagine doing this cutting. And then iterate. 1/8 is the amount such that if I took 8 copies of 1/8, I would end up getting my whole. That is, you'll see, I hope, will give you a much more robust understanding of fractions. So 5/8, how are you going to describe 5/8 now? When you see 5/8, what do you think I want you to see?
5 parts of it.
5,
Parts of it.
and I'm going to say copies of,
8.
5 copies of what?
1/8.
1/8. What you really have here is 5 copies of 1/8. What's 1/8? You take a whole and you cut it up into 8 equal parts. One of those parts is an 1/8. And I have 5 copies of those. So what I want my students to see is partitioning and iterating, cutting out. 5/8 is 5 1/8.
Yes.
Where 1/8 is the amount we get by taking a whole, cutting it from 8 equal parts, and taking one of those parts. 5 1/8. In fact, what I do is I want them to say, at least initially, 5 copies of 1/8. And then after time, we shorten it. 5 1/8. And then after more time, we shorten it. 5/8. Yeah.
Scott, from your research on doing work with this, what's the youngest kids can start picking up on this and abstractly have a good understanding of it?
Abstractly,
And I'm not saying doing the invert multiply and all that kind of stuff, but they really can start getting their hands
Early.
early. Like
Yeah.
Cutting
kindergarten,
and copying can happen really early.
like we're just maybe even almost kindergarten.
Sure, depending on the task,
Right, yeah.
you know, and maybe you keep it halves and fourths.
Yeah,
And
but-
that's, in fact, it does happen. You look at the Common Core standards,
Mhm.
I don't have it exactly in my head maybe, but like as early as first grade, they're at least cutting and copying and doing one halves, and maybe one fourths. Yeah. 5/8 is 5 1/8, where 1/8 is not such that 8 copies of that amount put together make a whole. You know, this is the kind of language I'm expecting now, 5 1/8. Now, think about this. Remember when I said that kids have a problem with, say, what are these? 9/8.
Yeah, 9/8.
9, oh, you can't have 9/8. Now, how are we gonna see 9/8?
9 copies of 1/8.
Yeah.
Imagine a whole, cut it up into 8 parts, think about one of those parts,
And then
and then
have-
copy it 9 times. You can have 9 1/8.
Yeah.
You can have 57 1/8. It's not a problem. Now, this is where it gets really cool. Well, a couple of summers ago now, I did a week-long workshop with some K-8 teachers. I did the whole fraction thing. We were literally cutting and copying and drawing, and we went the whole bit. But when we got done, this was so impressionable on me. We got done and we did this. What do you see? You got it. What do you see? I'm going to fix the camera.
I think what you want to see is that I have 1.5 divided by 4, so it's 1.5 units long divided by 4.
No, it's
No,
not.
it's divided by 1/4.
Then how many 1/4 units?
How many fourths?
Divided by 1/4.
How many little
Go
1/4
into
strips
one-
can you get out of 1.5?
Yeah, 1.5, right.
How many of these 1/4? Now, what's a 1/4? Can you imagine a whole something?
Mhm.
And my opinion is do rectangles, do circles, do whatever. It doesn't matter. Do them all. But can you imagine a whole of something, cut it up into 4 parts, taking one of those parts? How many of those will fit into, now what does this say?
1.5.
You have a 1 whole of something, plus you have an additional 1/2 of that whole.
Right.
How many of these are going to fit into that? Now, if you have this imagination and you actually have the experiences of cutting and copying with real stuff, now can you imagine? Have a 4th, have another 4th, have another 4th, have another 4th, well that's a whole, have another 4th, have another. How many 1/4 will it take to get into 1.5?
6.
I tell you what, when we got to this, and the teachers said, they didn't go, here's what they do at first. Oh man, oh wait, I can't remember how to do that. Do you invert and multiply? Do you first have to do 1.5, and you have to convert that to 3 halves, then you have to invert and multiply, right? And because I had K-8, the kindergarten teachers were going, hey Dave, you teach 8th grade, remind us how to do this. And by the end of the workshop, the kindergarten teachers are going, let's see, 1, 2, 3, 4. You can just see them. They can see it now. They've had all these experiences. They can see it. 1, 2, 3, 4. It's 6.
Well, if we teach them the rote, we also take away the common sense, because they don't know what's going on. And so, you know, the kids will get an answer and they'll get 6 and they think it's wrong because it's bigger
Yeah.
than 1/4.
Yeah.
And
When
they,
you divide, you don't get bigger numbers.
Yeah, that's
So,
probably.
you know,
But now, it
that's-
totally makes sense. If you're thinking about what this stuff means, it totally makes sense. Yeah.
Which is why all the second graders can't do math anymore, and they can't think anymore, right? Because they come in with that innate
Yeah.
sense of what's going on here, but then they're taught.
Then we kill their left parietal lobe.
I have a second grader right now, I'll see. I'll let you know.
Yeah. I do spend some time too talking about meanings of multiplication and division, and just this little side note here. What does it mean to multiply? You know how we usually say 3 times 2 is 3 added 2 times, or 3 groups of 2, that kind of thing? And that doesn't work so well, because 3 groups of 2 is fine as long as you have whole numbers. There's a group of 2, there's a group of 2, there's a group of 2. How many candy bars do we have? 6. But what I say instead of groups of is copies of. There's a copy of 2, there's a copy of 2, there's a copy of 2. 6 total. The reason I say that is because take 1/4
And copy it 6 times.
and copy it 6 times. And that whole cutting and copying thing now really makes sense. Take 1/4 of something. All right. So, would you agree that I have 1/4 right there? Well, actually, let me back this up. I'm not even gonna do it that way. Chuck, you can do it the community of property works. But I'm actually gonna have you do it this way. Take 1/4 of a copy of 6. Can Can you have a quarter of a copy of something?
Yeah.
I promise you can't, because every time I use a copy machine, at some point it goes, and then you gotta, even though the sign says do not touch, and then don't tell anybody, but I open the drawer and I pull everything out, and I grain the paper out, and there's a quarter of a copy on there, I promise. Can you have a quarter of a copy of 6? Yeah, look, 2, 4, 6. Cut it up into 4 parts, that's what fractions mean. Take one of those parts, and if you took one of those parts and kind of put it back together, I'd have a full candy bar and a half a candy bar. I would have 1 1/2 candy bars.
I like that.
Just do cutting and copying. What if you have 3/4 of a copy of 1/2? What if you have 3/4 of a copy of 1/2? So here's how it goes. There's a whole. First, you got to cut it in half. Now I'm going to take 3/4 of a copy of that. So I'm going to cut this up into quarters,
And then look at 3.
and I want 3/4 of a copy. 1, 2, 3, right? So if you go back to the whole, 1, 2, 3, 4, 5, 6, 7, 8, wouldn't each one of these represent an eighth of the whole? Yeah, it's a quarter of a half, but it's an eighth of the whole. So 3 of those would be 3/8. Now what I do, and when I did my Math 082 class, that's what we did. We drew them, we cut them, we did it all, and then eventually somebody goes, wait, can't you just multiply the numerators and then multiply the denominators? Can't you do that? And then I put the poker face on, I go, oh, I don't know, can you? Convince me, make an argument. All right, so it's important that we have these meanings, and when you look at what does it mean, and by the way, with division, you would say, how many copies does it take? Instead of knowing this many copies of this, division is the inverse, you say, how many copies do I need? How many copies of this is in this? And the 6 just pops out. Now, how does this work with linear functions? All right, will you please take a look at this? This is in your packet.